Good morning, everybody. How's it going? I'm a happy bunny because Regal have finally released a firmware update for my oscilloscope, which I bought last year. So I'm going to install that later after the stream. That's going to be fun to see if they fixed all the issues with it. Anyway, moving on. Right, what are we doing today? We're trying to do, well, hold on. Too many files. Right, we're trying to sort out some of this stuff. Let me move this over so we can see. Yeah, there we go. So, yeah, yesterday made excellent progress. Hold on, the gardeners have just started their leaf blowers. Hold on. Those things are so noisy. Leaf blowers. There we go. The leaf blowers and hedge trimmers and cicada beetles. Right. Anyway, let's continue. So yeah, yesterday made great progress with the job planning. So we're trying to do a vertical slice now so that we can get sort of like the structure of this workflow thing sorted out, and then we're going to go back and improve all the different bits that need improving as and when time permits. But the idea is to get a vertical slice of this so that we can make sure that the whole sort of idea is workable. Yeah, rather than spending too much time on any one little bit itself. So yeah, so yesterday I did a bit more work on the choosing process for each parts. And there was a little bit of back and forwards, to-ing and fro-ing on the implementation. At one point, I had this thing, like, it was called assign process to part. Well, and then this, is it assign part to process? And then the way that it was being stored. Anyway, it didn't work out very well the way that I was doing it, so I inverted it and then renamed it all back again. Let's see where we're at. Code, yeah. Let's have a look at some code. Woohoo! Yeah, and he also poked around with Clippy a little bit yesterday as well. Yeah, okay, so let's make sure all the tests pass before we go anywhere. Test pass, nice and quick. Still good, yes, that's what we want. Righto, so let's have a look at it. Let's have a look. So we've got our tests for the planner. Here they are. And then if we ditch the cargo thing and we've got the structure, and we can see we've got this one over here, which is the assign process to parts test. Now, if you remember yesterday, before we could assign some parts to processes, we needed the parts, right? And in this test, we had a CSV file with a list of parts in it. And then we ran the command with a bunch of arguments, and at the end of it, we said we wanted to have some JSON, some project state serialized as JSON, right? And in that, we wanted to have some part assignments. It turned out to be quite a faff to do that, because you can either have no assignment for a part, as in you know about the part but it's not been assigned to a process yet. So in that particular scenario, you have a list of processes, which is an enum, right? But you haven't picked one of these processes. So then do you use an optional enum? And then if you use an optional enum, at that point you're dealing with essentially an object, and that doesn't work for map keys in JSON. Yeah, so in order to use objects as keys in JSON, you need to get somewhat creative with your serialization, deserialization library of choice. So what we've ended up with is an array of things. One of the things contains an object, which is the part, And then the next thing it contains is another object, which is the state of the enum, and if it is assigned to a process, the name of the process. Yeah, it does work. It was a bit tricky to get there, let me tell you now. Yeah, so let's have a look. So in the what's it called? In the planning thing. What have we got in planning? Yes, in the planning mod. That's what I'm looking for. We have our project, and we got our process part assignments. Yes, and initially we had this hash map thing here, and the hash map was a process and then a part, but that didn't work out well. And then I tried optional process and part, and that also didn't work out very well. Then I flipped those over to make it the other way around, and that worked out better, but there were still issues with it that necessitated changing the hash map to a B-tree map, because hash maps aren't ordered. So what would happen is the test would pass, and then it would not pass the next time you ran it, because the order of things is different. So we ended up with the B-tree map apart to process assignments. The process assignment is an enum. It's either unassigned or it's assigned. I thought about using an option initially, but it sort of makes a little bit more sense to not use an option in this particular case. And then in order to make it work with Serde, we had to use this Serde as, and then we have to serialize this as a vector of tuples instead of a B-tree set, and then magically Serde as can somehow convert it from one thing to the other, which is pretty cool, and it does appear to work. So yeah, we learned something there, so that was good. One of the other things that came up is that when you initially assign the PCB unit to a process, at that point you know about the variant and the design. So I decided that all of the parts should be unassigned as soon as you add a new design variant to the project. So the CSV got used earlier in this. So the CSV actually got used in the second bit where you assign the variant to the unit. So we've got our placements and we write them out. And then when we run this operation, it goes, oh, you've got a new one. Okay, let's make them all be unassigned. And it does that now, which is good. And then when you finally use regular expressions to assign them to a particular process, they then end up being assigned to the process that you specify. The regular expression matching turned out to be fairly trivial as well. That happened. Where are we? The regular expression mapping. Yeah, it was simply that, which was good. So you basically just go, if the manufacturer pattern is a match for the parts manufacturer, and the manufacturer part number pattern is a match for the parts manufacturer part number, then away you go. Then you can reassign it. Some of the more tricky bits to do with this is that if you change the parts that are in your variant, you need to have this list of parts that's in your project updated from the parts that are in all your placement files that the project uses. All right? So what can happen is that you can end up with additional parts being added to your variant. Say you forgot to include a ref.des in your variant, then you go back and you change your variant, you add the ref.des to it, and now suddenly you've got this extra part, right? Then that part then needs to become unassigned so that the state of the project can be there are unassigned parts. Don't try and build this yet, right? So that meant you had to basically detect which parts you knew about and which parts you don't know about, and then doing something with the new parts versus the old parts and the old ways. So that was quite a faff as well. It's not well tested yet at the moment. And there is room for improvement in that regard. But the way I did it was, when you first assign the variant to the unit, you pick all the design, you find all the design variants, then you find all the parts for all the design variants, and then you refresh the assignments. And if it's a new part, and as part of this refresh assignments, it basically goes, well, is it... Hold on a second. Yes. If it's a new part, then make it unassigned. And if it's not even in the list anymore, as in, say you removed a ref decimal variant, and now it's you previously assigned a part to a process, but now nothing uses this part, you have to remove it from the list of parts assigned to a process, right? So you have to deal with these two changing lists. So that got done. Then, when you're assigning a process to parts, it first refreshes the assignments again, as in it adds adds new parts as being unassigned and deletes old parts that aren't used anymore, and then it applies your patterns that you specified on the command line to any matching parts and adds and assigns the process. And it uses the same find changes, and then depending on whether the part was new, existing, or unused, it will then apply some logic to it. In the case of, where is it? An existing part, because they will all be existing once it's been refreshed, then it can then check the pattern against the part, and then it prints out messages only if the assignment is changing. Yeah, it was fairly complicated. It was fairly complicated. Anyway, so that's where we're at. That was quite a bit of work, that was. Yeah. Right, so the next thing we're going to try and do today is creating a phase for each process and then doing the loadouts for each of the phases. So yeah, let's get into that. Let's get into that. Alrighty. Creating a phase for each process. So let's go back to our test. So at the end of this third sort of stage, the third item in this sequence, right, we should have a project with some processes and then some parts assigned to processes. Great. And we said we want to create a phase for each process. So let's start with doing that. Let's copy and paste bits of a test and fiddle around with sequences and all this kind of thing. And we have to rename the fifth one, and this has got to be 5, and then this is going to be 4, and this is going to be 4. And we wanted to create phase for each process. Let's just call it create phase. Seems reasonable. Right, we definitely want to run a command and print out some trace content. And in order to run a command, we need some args. And we want to use the same args that we had before. Except that this one will be something like create phase. I don't know what the arguments are going to be for this yet. Does it just create an ordered like thing? Do we name the phases? Do we have default numbering for the phases? Do we care about names for phases? What if you want to reorder the phases? Probably they should have like some kind of, I don't know, should it be an automated name? I'm not sure, I don't know. Let's just give it a reference. Yeah, why not? Let's call it phase 1 as the reference. Seems reasonable to me. Yeah, and I suppose we're going to need to be able to update the references and so on at some point in the future. Yeah, fine, okay. So creating a phase. And then we said we want to create a phase for each process. So I suppose and then if you're doing a single-sided board, you would have one process, pick and place, and then you would create a phase for it. Let's use slightly more real-worldy side 1. Let's say top 1. Yeah. Because maybe you've got multiple phases for the top and multiple phases for the bottom. Let's say top 1. Yeah. Okay. Okay, I'm happy with that. Okay. Right. That seems reasonable. So yeah, I guess we need to have the phase, the process. PnP, right? Is that right? And then, well, yeah, I suppose. So, because when you're creating your loadout for a phase, you need to filter all the parts by the process that they are assigned to in order to build a shortlist. Yes. So a phase needs a process, yes. Okay, fine. Okay, so then let's say... Now, I'm not sure about this particular thing that I'm about to do. You'll see why in a minute. Right, so we're going to say, and the expected CSV content is going to be the same as it was a minute ago, but we'll come back and change it in a moment. And I need to fix all these job status content names because it got renamed at some point and these didn't. So let's fix up all of these. So this is project content. Wait, what happened there? I don't know. I press return. Oh, I see. I press return and there's a thing there. Right, project content. Right, there we go. So project content, expected project content. Everything's good. Oh, this file is getting quite large. Right. So then what we need to do is somehow add something else into here. Maybe here. Maybe phases. Which is probably be an array. And then each item in the array is probably going to be some kind of object. And it's going to have a name. And a process. Yeah, why not? Something like that. That's what we're trying to do. Okay, all right. Let's run the tests. No, it wasn't that test though. It needs to be this test. When it's all tests, not all tests. Right. So we've got an unexpected failure because it doesn't know what create phase is. Right. Yay. Yeah, that all seems okay. Yeah, okay. All right, let's start creating a phase then. So we're trying to find the command. Here it is. So we've got a new command, which is going to be create phase. And we're going to have the process as before, and we're going to have our reference thing, which is just going to be a string. I don't think we need a special. I mean, we could. Do we want to follow the same pattern as we did for like variant name and design name, or do we want? Not sure. Let's follow the same pattern as we did before. Let's create something called phase reference. Well, how about just reference? Yeah, okay. Let's do that. Reference is a bit overused in Rust, so you know. Yeah, we're just going to follow the same pattern. Oh, copying and pasting. It's the best way to program. Probably we could use some generics here. I don't know. Or maybe we could use a macro. I'm not sure. And then we need to be able to display it as well. Sure. Like copy paste, right? It's not very right. So now we've got this. Can we import this? Yes. Yay. Okay, so we've got that, and now what happens? Well, nothing, because it doesn't compile, because we have to do it here. Something, you know, we're going to need to load a project, save the project. We're going to need the process argument, like so, and then we're going to have to use the process and the reference somehow. So probably we're going to have another B tree set of like phase. Let's go, I don't know, project dot well, we've got this add assignment. Let's say add phase. And I guess we need the reference and the process, right? And it might fail, I suppose. Yeah, why not? So in our project thing, and it's probably added a new implementation here where we've already got an implementation. Let's see if we can find the implementation for project here. Here it is. Yeah, we've got. See, the IDE keeps creating multiple implementations. It's really annoying. Let's cut this, move it here. I don't know why it does that. Right. So, you know, same kind of thing as this. And perhaps now's a good time to fix this little to-do, or maybe somewhere soon. So let's create first. Let's say let phase is a phase with a reference and a process, right? Right, and then we'll go self.phases.push phase. And we'll just put that same to do here for now. Right, but we don't have phases, we don't have a phase. Let's create a phase. Right, it's going to need to be serialized and deserialized, and it's going to have a process, and it's going to have a reference. We said in that order. Right, everything's good. We need these on it because otherwise we won't be able to serialize the project, because all the things in the project, the whole project is supposed to be serializable, so we need it on this as well. So fine. So we've got our struct phase, but we don't have that in a project now. We should be able to automatically create this. Yeah, well, maybe not. Now, I'm just going to do this to start with. I'm not reordering these yet because it might have an impact on how the object is serialized. Let's see what happens. Yeah, this add assignment thing here can potentially fail. Yeah. Right. So let's sort of bring some parity between these two things. This needs to be mutable. There we go. Right. What? What do you mean? What do you mean phases are more private? Oh, is it because this isn't pub, isn't it? Yes, certainly public. There we go. Okay, now what happens? Well, we broke all the other ones. And the reason we broke all the other ones was because now when we try and serialize it, initially they get put there. Now there's a couple of ways we can either go back to the test and start adding the empty things in it, right? Or I don't know, maybe we can tell Serde to just like skip the field if it's empty, perhaps. I kind of fancy that so that the tests are smaller. It doesn't matter that much. Let's see if I can find this. Here we go. So Serde skip serialization if empty. Yeah. Oh look, there's a skip serialization if. Let's have a look. So we should be able to say is empty. So it just needs to return a Boolean. Let's see if we can make that happen. So we've got this phases, and we're going to try and we're going to go, what is this? Vec is empty? Maybe? I mean, yes, that appeared to work. That's good. Don't know why this one didn't work. Missing field phases. Yeah, then it tries to, and then it's like, it probably needs a default value if, okay then. So when it's trying to deserialize it, it fails because it's not in the JSON, and therefore it needs it, and therefore it needs a default value now. I don't know which is worse. Let's see if we can say default. Is there a default value for a field? Can you just use default like this? We should be able to do this like that, right? Hey, look how it works. Okay, so we should be able to apply the same thing as this. Well, this is going to be interesting because we're told to serialize the vec, but is it going to apply this after this? Or do we need to use a B-tree map is empty? Oh, I don't know. Let's find out what's this. Let's see what happens. Mismatch types. Oh, we confused it there, didn't we? Is B-tree map is empty even a thing? It apparently is. That's good. Okay, then that was interesting. Right, good. So this one is now failing because of this, and honestly, we can get rid of this as well, actually. So let's do that too. Right. So now it just prints out this. That's our minimal project, which is good. So let's poke this and say, no, we don't care about those until later. Oh, what happened here? It's probably a comma. Yeah. This one. Okay. Right. All the other things are fine again. This is good. But what happened? Oh, well, I put a name instead of reference. Fine. And I've got a comma in the wrong place. I mean, we're pretty close here already. This is great. This is great. So this is supposed to be reference and no comma. Ah, it's great. But we broke this because we've now added a new thing. So we've got this now, create a phase. Now, arguably, we could reorder these and put them in alphabetical order, but I'm not sure we want to here. And we're done, but we're not done. Because we don't have our test for help for create phase. So let's do a help for create phase test. Create a phase, probably. I don't know. Oh. And this is going to have a couple of arguments on it. Let's get it to tell us what they are. Here they are. Oh dear. Oh no. Let's not do it like that. There we go. And those arguments need to be specified up here, somewhere around here. There we go. Okay. Getting there. So we've got create phase. We've got create a phase. Is create a phase? Yeah, I think we want to create a phase, don't we? Create a phase. Okay, no args. Create a phase. And then here, what's this? What's the problem here? What's the problem? Who can see the problem? Print. Oh, the indentation of this one. There we go. Look. Yeah, this bit. I'm still struggling to read these error messages. My brain doesn't grok these very well yet. It's getting there. It's getting there. Hey, and everything passes. We've created a phase for it. Everything's done. No, it's never done. It's never done. Now, what are we missing? Who knows what we're missing? I know what we're missing. What we're missing is some informational messages when we do something, because at the moment you run it, it doesn't even print anything. It just saves a project file, which is not very user friendly. So let's add an assertion in our new create phase thing to say that it should contain something, right? So we want to assert the trace content, and we've got this trace content, and we need to add an assert for it. And we want to say something happened. Something like created phase reference and process. I don't know why I'm putting these here. This should be PnP, and this should be top one. And there should probably be single quotes around this as well. Okay, so now we should have a failing test. Yay. Does it fail for the right reason? Yay. Okay, so let's make it print this out. So we've got this create phase, we've got create, blah, 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 blah. Here we go. So we go in add phase, and if it adds it, and only if it adds it, we're going to go info, and then whatever. And then we replace these bits. With the reference in the process. But of course this is going to be a bit of a problem, because unfortunately we pass both the reference and the process over to this add phase thing. So here we cloned the things before we passed them over. So let's follow the same approach here. All right, and then process. Oh, it needs to be a debug. Because we haven't implemented display. I may go back and implement display for these things, but not right now. Right, what happened? Expected this. Content was this. I mean, the casing is different. Right. That's easily fixed. And, you know, this is sort of why we might go back and implement display for it, so it's always lowercase. Let's have a look at the help thing, because when we create a phase, the possible values here are like P and P. I don't want to deal with it right now. We can improve it later. Right. We can create phases. We've got a project file with phases in it now. Amazing. Right, we're done for today then. This stream's finished. No. No. There's still more to do. I didn't think this particular thing was going to take very long, and it didn't. Which is good, because that means we can get on to the next thing that needs doing. But first, let's do a commit. What did we do? We did some stuff. Planner. We did some improvements here, but that's not the main thing that we did. The main thing that we did was creating a phase. Create phase. I suppose. And then I guess one of the other things that we did was what we were just looking at a moment ago, which was don't serialize empty lists. Don't, or avoid. Yeah. Avoid serialization of empty lists. That's another thing we did as part of this commit. This error keeps coming up like this. I'm not sure. I will look at that at some point, but not right now. Okay, that's all good. So that's the test done. Let's just review that. Move that over a bit. Check for white space and all the rest of it. So we've got project content, we've got a command, expected project content with all these same assignments, and then we've got a phases block. And then we've got our args, and we run it, and we have some trace content, and we assert the project content. Everything is good. Yeah, well, that's pretty good. And then we've got the help for it, which is fine. Yeah, all good. So what did we do in this? We added a new command with 2 arguments, and we made it so that add assignment can fail, and use the same sort of pattern for the create phase thing. Yeah. Right, so that's all good. And then in the planning mod, we poked around with the serialization stuff, attributes, and we reordered some code and added some to-dos. Yes, we'll probably deal with that in a moment. And we added our reference thing and the implementations for it. Yeah, no, that looks good. Dunsky-doo. Okay, let's fix those 2 to-dos that are in this. Let's fix these. So we said that it can fail, and the reason it can fail because it might already exist. You shouldn't be able to have 2 phases with the same reference, and you shouldn't be able to assign the same unit twice. Right. So adding things to something here is no bueno. So we use this B tree map thing, And the keys need to be unique. Yeah. So let's use a B tree map for these two things as well. Or should we? Or is it just a hash set? But hash sets are unordered. Do we want an index map? Do we want an index? Oh, I don't know. Oh my gosh. God, I don't know. Don't know. So we've got these binary trees. It's not really a binary tree because we don't have a key and a value. It's just like a thing. And all of the properties in it. No, is it all the properties in it? I don't know. Let me go back and look at this for a moment. So we've got a vector of unit assignments. Now, if we had a B tree map where the key was the unit path and the value was a design name and a design variant, that would prevent multiple insertions of the unit path into the tree. So, where's this used? Right, we've got this add assignment. So, this add assignment is creating a unit assignment prior to adding it, right? But if we didn't do it like that and did it a different way, such as by passing the unit path as just passing these all as arguments, basically, to add assignment, then the implementation of add assignment is free to model these assignments differently. Is this a detail? I mean, technically you could create a unit assignment and then not store it like that, but just pull the parts out of it. But I don't know. I don't know whether that's useful. Because at the moment we've got a design and we've got a variant, but we don't have what the thing where we use these two things together all the time, because they are used together all the time. A design variant. Let me look at this. You see here, unique design variants. Build unique design variants, and it returns a vector of a tuple of these things, you see. And this is another place where these things are both used together. And when I wrote this, I didn't like it. And I feel that this next thing is probably going to do something similar. So, okay, let's change this. Let's change this. Let's say we want to, instead of doing this, we're going to go project add assignment, and we're going to pass it the unit path and then a design variant, which is going to have design of design.clone and a variant of variant.clone, right? And it could fail still. Right. So we don't have this design variant thing yet. So let's find where we had this unit assignment. Unit assignment was here. So let's steal that, delete this from it, and rename it to design variant. Everything's fine. Right, good. Now we can import it. And oh, I see. It's got this needs to be design name, and this needs to be variant name. But it's still moaning. Why is it moaning? Right, because the arguments are wrong. So let's go back to this and just comment it out for the moment. No. Don't do that. There we go. Right. And then find the bit of code that we just commented out, which was here, and put our new one in instead. And this is going to be a unit path and a design variant. Wrong brackets. There we go. Okay. So then I suppose we go self.unitassignments.entry unit path dot insert or something like insert and then design variant. I can't remember the API. It's something like that. And we've still got to deal with this potential failure. Let's put that there. Okay, let's go back to this unit assignments and change it to a B-tree map. And it's, oh, I pressed the wrong button there. B-tree map of unit path to design variant. Sure. Right, and then we're going to have the same problem with the serialization because the unit path is an object. So we're going to have to do this. And we want to skip serializing it if there's nothing in it. Still, which is fine. Okay. Unit path probably doesn't have serialize on it. Oh, it does. We're okay. Design variant. Yeah, that has it. Okay. Not quite sure why it's moaning about that. Let's just run things. Oh, yes. This is because we need to use the B-tree map is empty instead. Okay. Right. Now unit path needs to implement some other things. It needs to have partial ord and ord. And it's going to need EQ as well. Right. Because all the things you put in a key need to have all of these. Right. And because it's a string, the characters in the string can be sorted, then it works. Right, so insert. It's not insert. It's or insert. This needs to be mutable, so that's fine. But like, how do you make it fail? So you either find the entry for it or you create a new one, but that's not what we want to do here, is it? No. I mean, we prevented putting it in twice, but it's still not doing what we want. Still not doing what we want. What other options do we get? Like this entry method. It gives you an entry. But what if it's not in the tree? What do you get? Well, what are you supposed to do? Let's look at entry. Maybe it's like, oh, I see. Look, you get it's an enum. I didn't know that. So if it's occupied, what do we do? What do we do? What do we do? Do we update the assignment? Do we tell the person? Do we tell the user that the assignment has been updated? If it's there already? Let's say let entry is whatever. Or let's go match whatever, right? Let's take this and add the patterns, right? So if it's vacant, I mean, what are the things in this? You get a vacant entry with key value and an allocator probably. And you can probably do things with it. Yeah, okay, fine. Let's see what we can do with it. If it's vacant, we can probably get the entry and insert the design variant. Sure. And if it's occupied, what can you do? Can you replace it? Can you just go a star entry equals design variant? Ooh, I don't know. I mean, it's already inserted. I just want to update it. So occupied entry, we've got a unit path and design variant. And get gives you a reference to it, which isn't what we want. Can you do a what? Can you borrow it? I don't know. Maybe you just do insert on it too. That's interesting. Is it because it gives you the old one and returns the old value? Yeah. Okay, so let's say let old value is this. Right, so at this point we can print out useful trace messages. And at the moment this is called add assignment. Let's say update assignment. And if we say trace, and we say updated assignment, and we'll say what the unit is, and we're going to say old, new. Sure. Unit path. Old value, and then design variant. Sure. Do we not have clone on this? Design variant? No, we don't. Now it's complaining because unit path has moved. Sure. Okay, cool. We can update this to be the right thing now. Right. So this is one trace log, and then the other one is different. Now, we're going to have to poke the test a little bit. Because our information logging thing is this. So we've got that. Let's say unit assignment updated. Unit assignment added. We've got created here, and we've got these things. So we'll delete that. and this bit of old code, and then we'll go into the test and we'll update it so that it does this now instead. Yeah. Right. But the build unique design variants thing is a bit different now. The implementation of this is going to be different because what was in this was those unit assignments, but it's not those anymore. So we get an item which is this now. So we've got so here now we can go path and design variant, probably like this. There we go. We're going to try that. So it creates a new design variant, which is at the moment a tuple, but we're going to fix that to be a design variant like this. But we've already got our design variant here, so we don't need to create it anymore, which is great. And we don't need to create a reference to it because it already is a reference, but we probably need to clone it. Oh, and this needs to be design variant now. There we go. But design variant needs to have partial EQ on it. There we go. I'm not sure if we need this clone here. Pretty sure we do, but because this one is the one that belongs to this, we can't take it out of that. Right, so now we've got this build unique design variant. Everything's fine here. So now this load all parts needs to be updated to take a list of design variants. And it needs to be something like that. Yeah. I'm not sure why this is. Oh, I think this is a bit of leftover code. We can get rid of that. Okay, let's run everything. Well, it compiled. That was good. Right. And then there's going to be a few things that happen now during this refactoring. Some messages got changed and the format of the JSON structure changed. But let's have a look at the last test to see if everything still worked. Like, we want unit assignments where we've got this, which is good. And this is our new sort of grouped object. And then we've still got our processes. We've got our process part assignments. And we've got our phases. So it all looks pretty good. Let's have a quick look at the difference in the diff. So this is what we changed here in this unit assignments thing by changing it to a B-tree map with an object. So yeah, so it looks like that. So we're going to take this. So instead of having a simple list of these, we've now got a B-tree map. So this one needs to be updated to have what's in my clipboard, which I can't remember if it was just this bit or it was the whole list. I think it was this whole bit. Right. Let's have a look. Right, so this still fails, but for a different reason. Because somewhere down here, there it is, we changed our messages. So this is what we're saying now. And we want something between these two. So let's go back to where the assignment was added. Not that bit. I can't find my code, I just had it. We'll find it eventually, but not there. This one. It's in the project implementation, isn't it? Here it is. Okay, so we can get rid of this now. We've done that now, which is good. But we're printing out the entire design variant, and you know, we could split this up, and we probably want to implement display for these design variants. So let's do that. Right. And it's going to complain that display isn't implemented for it. So design variant. Yeah. Let's go impl display for design variant. And I think we're supposed to use write with the formatter, and then this, and then a dash, and then another one of those. Yeah, so it'll be self dot variant name. No, design name. Yeah, self dot variant name. Yeah, that's okay. Let's try that. Okay, it's good. Let's have a look at the log now. So the log now should contain something useful. Here it is. So now it looks like that. Is this acceptable as it is like this? So unit assignment added. And we say whatever the unit was, and then we've got the design variant like this with a little dash in the middle. This looks fine. So we're going to update this to say make sure it prints out that. Great. Something's still failing. It's failing because we have to update the unit assignments in the second one. I thought we did that. Wait, what? Oh, it's just a white space problem. Fine. Okay, so it got messed up somehow. I'm not sure how that got messed up, but it did. Okay. Right, now we're on to the next one, and this will be the same problem. So we'll update that. And this one will also be the same problem. And we probably could do a bit of refactoring the test to like build this up in like chunks or whatever, so that the chunk is defined in one place and then the tests use the same chunk, and then only show the chunks that were different when they're building it. Perhaps. Hey, everything's good, right? But we've got some things. Now we've got this unit assignment thing. Yeah, we don't care about the path. Right. We've got this unit assignment thing, and I'm not sure whether it's even used by anything anymore. So we're going to have a quick look. And no usage is found, so we can delete it. Fantastic. Everything's good. Run all the tests, everything's still good. Let's do a commit. What do? We futzed around with unit assignments. So you can't really tell from the test what we did too much, but you sort of kind of bit, but not too much. Yeah, and there's a test for the other case where we insert, where we're changing it, and we haven't got a test for that yet. I know. Yeah, it'll come out when we start to look at the coverage reports of which code is used and which code is not, and we can look at it and go, oh yeah, we just need to create some tests for this. Yeah. We need to do coverage review at some point. But currently we're still focused on building the vertical slice and doing each of the little bits on this before we move on to all the detail and where things could go wrong and all the error handling improvements that one could make and all that kind of stuff. So focus. Right, so we refactored unit assignments. There we go. That's probably all we need. Oh yeah, and introduced design variant. Great. So that's our design variant. That's where we put the details of creating an assignment inside the method itself, and we renamed it to be update assignment. Fix that little warning. Unique design variants. It's this stuff. And then, we've got the same problem here, so we don't need that. That's fine. And then we changed that a little bit, and we had to change the way that we iterate over stuff. Okay, and we deleted some other stuff. Fine. And this is where we refactored it, so that's all fine. This is where we refactor the assignment updating. Now, this currently returns a result, but it can't fail. Because we renamed it to be update assignment. Can't fail. That's interesting. We might have to come back and have a quick look at that. But I want to look at the other one that was the same as this, had the same to do, and then we'll come back and update them both, I think. Because we've still got this one, right, to do in a moment. And this was where we changed the tests and where we cleaned it up there a bit, yeah, and then the other bit the same, right? Fine, everything's good, all good, everything's happy, right? So let's find that other to do. Where was it? This one. So this is basically going to be the same kind of thing. So for a phase, the reference should probably be the key, right, in the map. But if you took the reference out of the phase, the only thing the phase would have in it would then be the process. And I don't necessarily think that's a good idea. You know, and the unit assignment, now we don't really have a concept of a unit assignment, we just got this map thing. Yes, yeah, maybe you should, why, I don't know. It's probably, maybe, maybe that wasn't the right way of doing this. I don't know, now that I look at it. Let's see what else we can use. Oh dear. Right. That's a B-tree set. Didn't know this existed. What does it do? An ordered set based on the B-tree. B-tree maps. Yes, I don't really care too much about the logic errors, but it'd be nice if it told you a bit more about what you're supposed to do with it. An ordered set. We definitely want ordering, and we definitely want a set of things. Let's try using a B-tree set, right? And then maybe we go back to that unit assignment and use a B-tree set for that. Yeah, maybe B-tree map wasn't the right thing to do. Okay, we'll find this out. Ooh, look at all the testing. Fine. Okay, fine. So phases, no. Let's just say B-tree set. B-tree set. Okay, phase needs to be able to be ordered. So we're going to need partial EQ, EQ, partial ord and ord. Oh no. And we're going to need EQ. And it's then probably still moans about partial ord. Yeah, fine. Partial ord and ord. And then we need the same thing for the variant name. Sure. Oh. Okay. Let me take those back off. It was supposed to be on process. Okay. Right, so initially we're just going to go, do you go entry on this? I don't know. Phases dot, oh, you don't have an entry for this. I guess you just have a, and what it tells you whether you inserted it? No. Replace. Huh. How are you supposed to use them? You go insert, 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 insert. Everything's fine. But what if it's already in there? What happens if you try and insert it twice? Let's see if we can find the insert method. Right. And this returns a bool. Adds a value to set, returns whether newly inserted. Yeah, you see, I'm not sure this is right. This isn't right, because what we're actually looking for is a phase, and if the phase is already there, we need to change the process of the phase. So maybe it is just a B-tree map of a phase reference to a phase which contains the same reference. And then if it's already there, then you update the process for it, right? Okay. Yeah, I don't think a B-tree set is what we need here. It's no good. It's no good. Yeah. Oh. I think it is a B-tree map of a reference to phase, but a phase is, there's a bit of duplication. I'm not worried about the extra bit of duplication. Not really. It's not like we have hundreds of phases, really, is it? It is going to make changing a phases reference harder, though, if we do it this way. Because yeah, it's not the end of the world, though. It's not the end of the world. Okay, we're gonna go with it and see what happens. Well, let's just do this. Right, here we go. Let's try this. So we're gonna do the same thing, and then it needs to be B-tree map. Sure. Sure. So we're going to go. We'll do the same kind of thing as we did before. We're going to go match self.phases.entry, where the entry is the reference but cloned. And then if you've got an entry, then great, you can do something with it. And you can go, if it's a vacant one, then you insert the phase. Let's move this here. Yeah, okay. Insert. And it's moaning at us because I missed the semicolon. Fine. We can delete this now. And if it was already there, and we don't have a test for this, I know. We can go entry dot I don't know. Can we do a get mutt? Oh, we can say existing phase, and then go existing phase dot process is the new process. Or do we just build a new one and just replace the whole thing? Seems reasonable. Yeah. Okay. Well, that's quite interesting. We don't use B-tree set anymore. Fine. Okay. Then what happens? Right, so creating phase. Do we have a phase? We do have a phase. But the way that it's stored and serialized is different now, which is what we want. And this is what I was saying. You've got this duplication here, but you know, unless we introduced like some random identifier for it and generated one when we first create the phase, then how can you put it in a map, right? I mean, we could create an ID for it, but I don't care about IDs. Yeah, so we're just going to use the reference as an ID. And everything will be fine. So we should see a difference here now, which is this. So we're just going to grab our phases bit and update the test to match it, I suppose, really. I mean, it's a little bit further away from what we originally wanted. But now we know that we can't repeat it because there was nothing in the way that we were previously storing it to say that we couldn't repeat the information multiple times. Right? But if we use a set with a key, then it's more explicit. So we've got the key here, and then the value is all this. Right? Yeah. Sure. And everything's fine. Now, just for chits and giggles, right? Now we wrote some code. but we don't know if any of it works yet. I don't really want to test it too much, but I just want to quickly eyeball this failure scenario. So the other bit of code we wrote was if it already exists, then change it to be something else. So if we make it exist by temporarily adding it to the other test, no, we can't do it there, can we? No, not very easy to test. We'd have to sort of run this one like twice or something, or pause it and then update the test so that it's got that thing in it, and then see if it changed it. I guess it wouldn't be totally hideous. Yeah, so let's put a breakpoint here. Run these in the debugger. Why? Did I screw something up? What did I do here? What did I do? Yeah, I did screw up. I didn't take off. This bit that I added. Let's just run everything again. No. What line is this on? Oh, there it is, look. Fine, everything works. Right, so now we can run it through up to the debugger. Right. So now before this phase gets created, let's open this file. No. Copy. Open. Open file. Okay. I don't like what they've done to Notepad in Windows now. It's really annoying. So this is the file that we've got, and what we're going to do is add the phase here. We don't care about the white space, and we're going to say manual, right? And it should deserialize it and then change it. When we say go. Let's see what it did. Oh. I wasn't expecting that. Yeah, I mean, okay. We only have one phase, we only have one process at the moment, so it's a little bit tricky to do. Wait a second. Phase for the process. Yeah. Yeah. Yeah, okay, okay. Yes. I think we're just going to leave it and worry about it later. Because I don't really want to get into the whole adding another enum variant to the process right now. It's probably good enough. Let's go back to the bin though. And in the bin we've got this created phase bit here. Right. I want to move this into that place where we just did some stuff. Thus. Yeah, and of course it's really annoying. You just have to keep cloning everything all the time. Oh, it's a bit of a faff, isn't it? There we go. So the test should still pass. There we go, good. And do we want an info here? I think we probably change this to info. And then we need another one over here, which is sort of going to be similar to this, but, you know, not. Updated phase. Now, there's a couple of ways of doing this. We could like copy the old phase out and then refer to the old phases process, or you know, we could do it like this and just update the thing that we want. Let's say let old phase is existing phase.clone. Do we have clone on phase? Probably not. Right. And now we can say old phase dot process, right? And then we can say process like this. Should be okay. Right, that's probably sufficient for today. We don't use trace logging now. Changed it to be info. Everything still passes. We're all good. Time for a commit. Right. So we've got our, what did we do? We refactored phases. Yeah. And we crossed off a to do. But we don't have any tests for some of that to do. Okay, fine. And we move this into the other thing. Yeah. Okay, commit. Let's run all the tests. Everything's fine. No warnings, nothing. Perfect. Okay, good. Let's push these. Okay, I'm happy with that. Push. Whee! That's good, and we got rid of some to-dos. Excellent. What's next? What's next? I think it might be time for a break. Not sure. Let's have a look. Let's see what the next thing is and go from there. So we've got create phase for each process. Yeah, I think I might need to think about this a little bit before I just dive into this. Assigning loadouts to each phase. Right. So probably where we've got our definition of phase, right, probably in here we're going to have loadout. And it's going to have a loadout name, probably like that. I don't want to put all the details of the loadout items into it. I just want to refer to it by name. I want to refer to it by name or by a reference to it. Right. Because you want to manage them separately and independently from the phase. I don't want to have to load up a phase out to futz around with the loadout items. So we're just going to have a sort of like a name of it. And then if you imagine you've got a directory with a bunch of CSV files in it which contain the loadout items, which will contain like the feeder name and the manufacturer and part number, then you can load up the CSV file for the loadout and use it, and everything's magic. Yeah, something like that is probably what we want. So that's what I'm going to do. That's what I'm going to do next. I'm going to take a break. Yeah, and I'll see how far I get on this, and I'll keep you guys updated with progress. Don't forget to click the like and subscribe buttons and all that kind of stuff if you find any of this interesting, useful, or whatever. Yeah, much appreciated. Alright, so just remember, folks, it's only software. How hard can it be? We'll find out on the next one.